this video, we are going to see address space segmentation of a process running in Linux. Why process address space is segmented? While executing a program, each of its instructions are loaded into CPU and executed in order. These instructions are going to do some operation on a set of data. So, for program execution, we need space for instructions as well as data. Thus, Linux segments address space into multiple parts to handle code and data into different manner. Let's consider this as the entire address space of a process. At first, there will be a segment to store the instructions. This is called code segment. As these instructions are going to be read and executed by CPU, this section is marked with read and execute permission only. Next comes the data section. All the global variables reside in this section. As these data are going to be read and write, this section is marked with read and write but not execution permission. Both code and data section are fixed size because their size is known before the execution starts. With the execution progresses, there will be necessity for data growing and shrinking dynamically. For this, we have stack and heap section. Local variables of each functions are stored in stack section and dynamically allocated memory are stored in heap section. Initially, stack starts at the bottom, actually above the data section, and grows upward. Similarly, the heap section starts at the top of the address space and grows downward. Let's examine the concept with a simple C program. In this code, if you see, this initially prints the PID of the program and then it waits for the user input. So at this time, we can go and examine the process memory map. After first user input, it calls a recursion function for 5000 times. So the expectation is stack should have grown upward. So when we go and examine the maps this time, we should see the stack has grown upwards. After next user input, this program actually makes 1 KB chunk memory allocation and then it waits for the user input. This time if you go and examine the map, we should see the heap has grown downward. Let's compile this and execute. The PID is 34540. So for PID 34540, the maps is available at /proc/34540/maps. This is the initial mapping of the process. Let's examine it in detail in a moment. Then after first user input, now the process has already called the recursion function 5000 times. This is the memory map after 5000 function calls. Now the process has made 200 KB of memory allocation. This is a maps after 200 KB of memory allocation. This is the initial memory map of the process. So you can see at the top, this is the code section because the permission you can see which is read and execute, and this is the data section, the permission you can see which is read write. The middle one, this is actually labels, so it stores only constants and other things. Let's not worry about it, it is only read permission. And as we discussed, heap comes here which is read write, and stack comes here which is read write. Let's try to put this in a pictorial representation. Let's take this as the complete address space. The code section starts at 55B11BE15000 to 55B11BE16000. The data section is from 55B11C016000 to 55B11C017000. The heap section is from 55B11C813000 to 55B11C834000. The stack section is from 7FE0CEC1000 to 7FFE0CWE2000. As you can see, this is at the topmost part of the address space. In the second image, we are seeing the updated address space after first user input. So after the first user input, the program actually makes 5000 recursive function calls. So the expectation is stack has to grow downwards. You can see the stack here. As you can see, the stack's top address is same before and after, but actually the bottom address got decreased. So the stack has grown downwards to new address 7FFE0C0B9000. In the third image, we are seeing the process address space after 200 kbps of memory allocation. So the expectation is heap is supposed to grow upward. So here is our heap. Heap starting address remains same as 55B11C81300, but the entering address has grown from 55B11C834000 to 55B11C85500.